Okay, welcome ladies, and so great to be here, and such a rare treat to have a room full of tech women to talk to. So I'm really glad you're here. My name is Ödgärd Andersson. I will talk a little bit about who I am, just so you know who's up here talking, and then I intend to talk about the company Zenseact, where I work. We're a software developing company that makes autonomous software and software for advanced driver support, and we're part of the Volvo Cars group. And I will also talk a little bit about the tech, because it's women in tech, so we should talk about the tech as well, I think. But before I start, I can actually moderate a bit, depending on what you are more curious about. So is there anything you would like me to talk about? Safety in the development. Let's see if I cover it. Otherwise, you ask me some follow-up questions. Okay? Anything else? Yes?
Product development in general.
Product development in general.
You're thinking around product development.
Okay, I'll try to do that too.
Code testing of the software.
The testing of the software.
Yeah, code testing so for security.
Let's see how far we get.
Long session.
I didn't actually intend to cover the testing, but that's a super interesting area, so why not? Okay, let's go then. And this works. Buckle up. I think we passed that part already. Where do I point this? There we go. So, towards zero faster. This is actually our motto in Zenseact. And it means something to us that we actually talk about quite a lot in our everyday. Towards zero is towards zero collisions. And I think it's obvious why we would like to go there. And faster is actually a lot around how we develop the software. Because in the auto industry, some of you I know are in the industry, we have come from a tradition of all our timelines being run by how you develop mechanics. And we have moved to products that are to a very high degree defined by software. And that brings a lot of challenges, but more than that, a lot of opportunities. And one of them is that we can roll things out all the time. And that means that we, who are passionate about going towards zero, can actually do that much faster. And that also means that we need to invest huge amounts of resources, hours, blood, sweat, and tears in building the actual infrastructure in the company to do things faster. So this is our motto. When we're in doubt, we try to go back to this. When we're thinking about should we do A or B, we think about will this bring us towards zero, and will it go faster? Okay, so talking about zero, this is a slide describing a little bit about the sad fact that traffic is not safe. So 1.4 million people die in the world every year as a result of traffic accidents, and 50 million are injured. And I mean, every one of those 1.4 million, we would have liked to obviously not have to have that happen. They all have people around them who are highly impacted by this. They're somebody's mother or daughter or brother or somebody's friend. How many of you know somebody who's been in a car accident? Yeah, quite a few of us, right? Or you've been in one yourself. And many of them are not that severe, but many of those 50 million also carry lots of injuries and pain that goes on for a long time, and other people affected by that. And on a societal perspective, we spend a lot of money taking care of people and trying to bring them back to exactly the good state they were in before they had an accident. This is all suffering we would like to remove, and resources we would like to spend on something much more useful in society. So this, for me, is really exciting, because this is the purpose of why we go to work every day. And going to work for a purpose is really, really nice. So we're about 500 people in the company, and we are a pure software company. So we don't do any of the hardware in the cars. We rely on our partners that we develop for to do that. But we do the software, all the software that takes care of the safety, the active safety systems, meaning that we actually help you when you're driving, or that we in the future will let the car drive for you. And the intent is all about going towards zero. We came to this from safety. We don't believe in automating cars just for the fun. It's fun, no doubt. And for anybody who's a little bit nerdy, I mean, probably many of us have had some kind of robot at some point, or in early days of programming. That's like the most fun thing to do, right? So it's definitely a cool thing, but we don't do this just because it's cool. We came from the angle of wanting to provide safety. We come from a very long heritage in Volvo Cars, always going for safety. And that is actually very good for us, because that helps us make decisions when we think about how to implement things. So we believe that automating away things in the ultimate scenario, letting the car drive for you, will improve safety, because we are not perfect as humans. It's actually amazing how good we are at driving. It's a rather complex task. So actually human beings are rather good at driving in general, but still 1.4 million people die. And it's because we're not perfect in all types of scenarios, and sometimes the situations are just too difficult for the abilities we have. And sometimes we're very tired, or we're medicated, or intoxicated, or something else happens, like a medical condition that, like you have a heart attack or something happens urgently. So the car can help you, and that's what we do. How we do it in modern cars, I will talk a little bit more about the tech later, but all kind of self-driving systems are based on understanding the world around you, observing with really good sensor, understanding what's going on, and then acting on that. And that in most systems, almost all I think, includes using machine learning to actually interpret what comes from the sensors. So we have deep learning system that understands what the world is, what the cameras are seeing, or what the other sensors like lidars and radars are seeing. And we have a lot of code that tells the car what to do. So, how many of you have followed the development of autonomous vehicles? Quite a few. Oh, wonderful audience. So, I've been in the automotive industry for about 6 years, and when I joined the industry, it was like the hype of the hype for autonomous cars. In 2019, we would more or less not be needing any more steering wheels, if you listen to some people when you went to like these big automotive shows. I think everybody who was actually developing things understood quite well that that was not going to happen in 2019. But there was a huge hype, and I think since then, in a very good way, like often happens with hypes, we have become a bit more realistic. So we have actually understood that it's highly possible to automate some scenarios, but it's going to be quite a long time before all cars can drive all over the place, on every single road, in every single country, and in all conditions. So we're not going to completely get rid of the steering wheels and let all cars drive themselves in the short term. But there are already cars out who can fully drive themselves in some places and some scenarios. And what's cool about this, and this could make us a bit depressed, right? We're 600 people, 500 of our own and some of our partners, trying to develop systems that drive themselves, and the hype is over. But what is really cool is that we realized when we went for autonomous driving, we had to amp up the tech level quite a lot. And that means we can make every single mile that you drive much safer. And that's every single car that will leave the factory with that equipment. We have the software, and it would absolutely not make sense if you want to move towards zero faster to have all that great equipment and all the tech we developed, all the software, and not use it also when you're driving. So in the next generation, the active safety systems that exist today in cars, they're quite rudimentary. The tech step that we're taking for autonomous allows us to use all of that. And just as you drive out the first mile with your car, those systems are active and they're helping you, even if you're not in a place where you can go autonomous yet. That's kind of cool, right? I'm going to share a little bit more about this. So this is a real picture of a street. and quite normal scenario. It's kind of difficult because a lot of things go on here. And if you come driving, meeting this street, you see some things, but you don't see everything. And the problem is that sensors like a camera that are in today's cars, they have the same deficiencies or limitations as we as human beings do. We can only see things if there's light on them. Right? So we solve this in cars traditionally by adding lights on cars. So you can, but they're not so great, right? They don't see that far. And you have to see, and human beings only see in one direction at one time. Some of us are mothers. We're kind of halfway to having eyes in the back, but not quite. So what you really want, if you want to be sure that you can see things, is an active sensor that can see things even if it's dark. And if you send out a light pulse and observe what comes back, that is a new type of sensor, relatively new. Do you know what it is? It's a LiDAR. Good. This is what it sees. It sees everything because it doesn't depend on external light to see things. And this system will go into the Volvo cars that are coming out in the new generation, in every single car, the EX90 that's being launched. And we have the software behind this to help the car drive itself where that is allowed, but to help you when you're driving, instead of seeing that. And this is a step function, because we can actually, and it's fantastic to work with Volvo Cars as our lead customer, because they have a lot of data on safety. And if you look into, and we've actually done this, really nerded out on the stats and gone through all the data, you can see that there are some cases where accidents happen. When it comes to pedestrians, there is a lot of accidents happening in darkness. And it's natural, right? It's hard to see people when it's dark. We will be able to see them when the world looks like this instead. And if you look at the impact of the LiDAR introduction as one thing, we have gone through all the really lethal and severe accidents in the database. And our quite conservative estimate is that we could take care of 20% of those with just the first level of this technology entering the car. And just as a 20% is that much, well, if you look at 1.4 million people being killed, that could be quite a lot of people in the long run, right? If you look at the seat belt, it was even a bit more impactful when that came. That helped actually estimated about 50% of the severe accidents if you had a seat belt versus if you did not. The airbags are pretty much on this level. When they were introduced, they could deal with about 20% of the accidents, provided you had a seat belt on. So this is a huge thing. It's all software. Of course, it's a hardware behind the actual sensor, but that realizes this potential. It's not the traditional kind of making sure the mechanics are folding in the right way. That safety system is still there, but now we're adding another one, and it's big. So a little bit about the actual tech, since you're a techie. I think I'm going to go for this slide, actually. So I mentioned going for automation means you get a lot of systems in the car. So we added cameras, and there are cameras in today's cars. The cameras are much better, like a 5x, 4x, 5x factor. 10 cameras, and this is the Volvo platform that we're launching our first version of this software with. We have driver monitoring cameras. Do you know what they do? They watch you when you're driving. And that is a good thing. They don't store what you're doing. They don't send it somewhere to somebody else, but they watch you when you're driving. And that allows us to know whether you're paying attention or not when you're driving. So if the car is driving itself, we have to know if you're ready to take over when that time comes. That's why we started introducing these systems. But we can use them when you're driving as well. So if you let your car drive for you on the highway, you take over. We know that you're ready to take over because the driver monitoring is watching you. And when you're driving, we can actually, in the future, start adapting the software for how attentive you are. If you're really there and really paying attention, we can have a little bit less of a forceful help. And if we see that you're dozing off because you're tired or you're looking somewhere else, we can actually let our systems be more active. So that's really cool. Driver monitoring. LiDAR we already talked about, very exciting. We have radars in cars today, and we will tomorrow. They're actually improving quite a lot as well. There's a new generation of radars coming up in a couple of years. We have ultrasonic sensors. They're kind of near field sensors with a radically lower cost than some of the others. And then we have a super interesting thing. It's called an HD map. And an HD map is high definition map. You use that to be really sure of where you are. And it's on a lane level precision. And why do you need that? Help me now. Sorry? Yeah, you want to know where you are. The line assist we actually do mostly through the sensors, and that's because you can't be 100% sure about a map. It's not seeing the real time. But what we can do is to see and plan a little bit further. So our sensors can typically see like a couple of 100 meters or shorter than that, 250 for the LiDAR roughly. But if you want to, like a driver, be very safe about how you plan your driving, you want to kind of think, if I have to be 4 lanes to the right in 500 meters, probably I don't want to be in the left lane and then panic like 100 meters before when I start seeing where I'm going. So this map allows us to, on lane level, actually plan further ahead. We can talk about like we have a horizon that's far beyond where you can see. And it also helps us localize exactly where we are and compare that to the sensing data. And then the SD map, that's kind of traditional navigation map. In the Volvo case, we worked with Google for a couple of years now, and they're also doing the high definition map. And we are together with Volvo and Polestar here, Google's lead customer for this. So we're the first ones doing this. We were also the first ones implementing the Google map in the car. This morning, I was going from coming here with a cab. And I hopped in the taxi, and it was a lovely man driving the taxi, but he really did not understand my Gothenburg accent. So I repeated that I wanted to go to Nils Erikssonplan 4, probably 8 or 9 times, and he was like, "Oh, what?" And then he finally I did a little bit better, so he understood. And then he said to the car, and he had a Volvo with a Google system, he said to the car in his accent that was also quite thick, that he wanted to go here, and it got it like that. And there's a power of working with really good partners in this, right? If you want to map out the world, it's difficult to be Zenseact with a few hundred employees. It's really difficult to be Volvo Cars. Sweden, the map would be fantastic. But in many other countries, not so much. And they have the access to data from every single Android phone user and every single car that deploys this. So that's good. Partnerships are important. Oh, sorry, I'm not through with this. So I talked about perception quite a lot. We have our sensors that understand things, and then we develop software. And here, when it comes to this, we have a massive focus on deep learning, as I talked about. But when it comes to actually telling the car what to do with this, actually sending a request to the car for what to do, we also have quite a lot of traditional code. So if you're a C++ coder and now getting slightly depressed over the focus on machine learning, don't be. For a foreseeable future, we will do quite a lot of C++ coding as well. But there is more and more machine learning happening, and it's actually expanding to more parts of the stack. It's quite exciting. It changes a lot how we work. Since the code is being generated more automatically, actually the algorithms are very much open source type of algorithms or things that come from research in universities. There's a really high emphasis on how you develop and how you actually build your tool chains and how you connect those to your safety cases so you have an automated way to kind of understand that what we're doing is safe. And the trick with autonomous driving is not developing something that can drive a little bit autonomously. My daughter can program her Lego robot to drive autonomously. She's 13. She could already 4 years ago. It's pretty much the same as a car. It has a few sensors that read the world around it, and then it does something. That's not hard. The trick is to do it in such a way that you know it will take care of every single weird use case in the world and be safe. And how do you know that? Because people are good at driving. Ideas? You can drive, right? That's how we used to test cars. Hop in the car and drive around, and then go on an expedition in Europe and find a few cities where we can. We still do that, actually, because we want to collect data. But it's totally hopeless to think that you can catch every single thing just going for a test drive. It's like looking for a needle in a haystack. So we simulate a lot, and we re-simulate and re-simulate again and again and again. And the beauty of where we are now is that we can actually start adding new data into our existing simulations. And that means that every time we want to launch a new software, which we want to do all the time, because we want to go towards zero faster, we can actually bring in all the learnings that come from cars out there and bring that into our simulation. So actually we can test drive the car virtually in the most horrible drive you could ever be in. We can even add kids that crawl under the car and in front of it, or other things by synthetic data, which we could never do. I mean, you would never throw a kid in front of a car, right? And we can try if we would have gone left instead of right somewhere, and all kinds of things that we can do virtually. And this is how we have to make sure that the cars are really safe. We also have to know that that actually represents reality. So when we do testing now and in the future, it will be a lot about actually validating that the simulation is accurate according to what happens in real life. Otherwise, we may build something that, a little bit like ChatGPT, is like, somebody called it the mansplainer of the year, right? It is quite good at a lot of things, and then it's equally convinced it's totally right, even if it's just bullshitting. And that could happen in our algorithms as well, and that cannot happen if you want to be safe. So we simulate, we collect data, we use the real-life data to validate that our simulations are right. We enhance our real-life data with synthetic data. One example is we're now launching, there's a new regulation in Europe that you have to be able to automatically read speed signs. You may think that's kind of a trivial problem, but you would be surprised to understand what people could do with speed signs. And the amount of different speed signs and how difficult it is to actually find them in real life. And there's a perfect example where we can just pump in every speed sign we know about synthetically, and then we use the ones we have for real to validate that the system is working the way it should. That's kind of cool, right? And then we, of course, develop features, and those are the ones you would meet in the car. So you would, for instance, meet something that keeps you in the lane, as you said. Or you kind of maybe don't want to think about exactly what feature it is, but you have an experience of the car helping you out when you're driving. And that's also, I think, a trend that we want to focus a little bit less on single features and trying to tell people that they have this and that feature in a car, but rather just give an experience that keeps getting better and better. To support us, we also have a cloud, and this, of course, important from the map perspective, for instance. We want to always have a fresh map, but we can also, we also use, of course, this to offload our data, and the whole idea is to deploy a software in the car, to drive in real life and collect data in real life, bring that back to us, take the learnings, improve our simulations, make new software, and deploy those over there. And for those of you who are not in automotive, it sounds like the most given thing in the world, that everything would be updatable and so on. But in the automotive industry, it's still rather new. It's only a few years ago since we started actually updating the cars over there. And this would just keep improving, and much more functionality will come. That means that your car is no longer at its peak when you pick it up. It's going to be actually better a year after that, and hopefully even better 2 years from that, and so on. And it's going to be interesting to see what that does with the value of a car. Okay, I think I've talked about this actually a bit, learning all the time. Over there, updating and learning, but it's also true for us. And I think one of the things that's most exciting about what we do is you think you have to learn everything about something. And I was just in a room where they shared how they had gone insourced their work and how everybody had to learn to work in a new way and new skills and everything. And then all of a sudden we realized that we're going to grow machine learning, and we just converted all our code to C++ that wasn't, and so on. And the next step is something else. It's fantastic. The world is not like it used to be, that people go to university and then they learn some kind of version of being an engineer and then they stay in that for 20 years. None of us are going to stay in anything for 20 years. And I think that's just awesome. I've moved around in different fields, and I think every time I did, I probably became at least a couple of years younger and much smarter. And it's so much fun. I hope this world never stagnates again like I felt it was in the 80s and 90s. It's a massive tech push. Do you agree?
Yes.
Yes. Is it fun?
Yes.
Is it terrifying?
Yes.
Yes. It's kind of good. It keeps you on your feet. Oh, maybe I should pause a bit for questions. See if you have something you want to dig into. Did I cover talking about how we're safe?
Yeah, a bit.
Any other questions? Yes.
You mentioned the LiDARs, and they are sending out light.
Yes, an optical pulse.
Yeah. How is that affecting if you have a bunch of LiDARs on the road? Are they affecting each other in some way?
They could. It's like all signals, they could potentially affect each other. I think one of the things with LiDAR that's most critical is that it can also impact humans that see. And you know that when we were in physics, you were supposed to not look at the laser, right? So actually one of the things, we have a partner that we work with together with Volvo and Polestar. It's called Luminar. One of their things is that they use a 1550 nanometer LiDAR, which is actually much safer for the human eye. But it could still potentially be impacted by others. And there's a whole set of, like with radio signals, a whole set of rules of what you can and cannot do and how you can pollute the world around you with signals. And it's actually interesting also that none of these systems are perfect. Radar is not perfect, and LiDAR is not perfect, and camera is not. The reason we have them all is because they have their strengths and their weaknesses. And with the different systems, we can actually use the strengths from all of them and try to ignore them when they're not that good. Yes?
And why do you think that we exactly you have Volvo go for the strategy of having different types of sensors, but there are still a lot of car companies that goes for only cameras. So why do you think that it differs so much in the strategy when it comes to sensors?
Yeah. Without name dropping, I can say this. I think the thing is that in order to let software evolve really quickly, you need to have a rather stable hardware that's rather standardized. You cannot have 1,500 different versions of hardware and try to test your software and make sure it's safe on 1,500 different versions. So the reason that some companies tried and still are trying for camera only, I think is actually cost. That allowed them, because at that point, LiDARs, for instance, were ridiculously expensive, like $70,000 expensive. They were like pure research projects, the good LiDARs. And there was no way you could put that on a car, and definitely not on all cars. You could do it on like a early RoboCab or something. So I think it was a cost thing. They deployed the best tech that they could afford to put in all cars. And now there's a new generation coming, and we see there's a big step happening. And I think there will be many more. This is super immature still, so there will be radical price changes and democratization of the sensing, which is good news for all the 1.4 million. Yes?
So you mentioned radar and a lot of sensors collecting data for safety, but how we make sure that this data is protected with this data?
The protection of the data. Yeah, it's a good question. First of all, it's enormous amounts of data. So that's a problem in itself. And we collect data like on a weekly basis that's equivalent to an average enterprise entire pool of data. And we can't store that because we would do, I mean, we already have a cost increase in our company that's mainly driven by data storage. So the trick is to filter out the situations that are interesting, because we have no real interest in storing data on boring driving on alone on a highway, nothing happens, right? But if something happens, we want the data, or if something almost happens, we also want the data. We don't, however, really want to know if you were there, or if you were there, or who was around the car. So the idea for us is to know as little as possible about, I mean, we want to know about the situation, and we want to know about patterns for many different cars, but we want to know as little as possible about the person behind, because then we can never be hacked or intruded or asked by the wrong people to share. So that's the kind of basis of the system. And there's a lot happening here also around the legislation on how you need to anonymize and so on. I think we will see much more. But we try to know as little as possible about the single people and just about the situation. Yes?
Are you looking into using like individual data? Are you looking into individual data in order to maybe optimize the driver experience for a certain person?
Yeah, we're not doing that right now. And this is interesting. Actually, most of the trend right now is that you use map-based data to adjust the driving, because it's so dependent on the situation around you. I'm quite convinced we will also kind of find patterns of some people like to be a little bit more center of lane and some like to be a little bit, but we're actually not doing that so much right now. The big trend in the industry now is to adapt to the driver behavior of all other cars that have passed, and you do that through the map. So if you see there's a speed bump, for instance, then everybody's slowing down there. You just do that automatically.
Talk a little bit about safety. In the safety field, do you think how much the test is enough for safety in Volvo, for example, do you have priority for X situation, or put some situation in high priority or lower priority, or how do you?
Yeah. This question is one of the journalists' favorite questions. Would you, hit a child, or would you hit grandma instead, kind of? So, or kill the driver, yeah. So first of all, how safe is safe enough? It's really hard to say, right? But there is no use deploying an automatic system if it's not safer than the human beings. That wouldn't make sense. That's the whole driving force. So we believe like factor 10 at least, probably more safer than human beings, is needed from automatic systems to start with, and then we have to improve from that point. If we talk about who would we prioritize, we don't do that at all. And actually, I don't think we do as drivers either. If you're in a situation, split milliseconds, something is about to happen, you try to avoid hitting something. And of course, try to avoid killing yourself as well, right? And we do that instinctively as human beings. The beauty of having an automatic system is that you can be more proactive. So we can actually let the car change lanes much earlier if we see a potentially dangerous situation up front. So our task is really to avoid you even getting into the situations where something could happen. If we get close to something happening, we will just try to avoid hitting everybody. And there is no way we could prioritize whether it should be an old or a young person or, people are people for us in this. We try to not hit anybody. A 0 is a 0. It's not a 1. Yes?
My opinion is like Scandinavia is very, very clear, like road lanes and so on. But internationally, not really using the Google Map, and the road is quite messy and more population. But I'm just curious about your simulation. How can you put like data internationally, or only the Scandinavia?
just with deep learning and machine learning for the case.
Yeah. You don't live in Gothenburg, I guess. No, because also in Scandinavia, in some places, the roads are not that clear. But it's a super relevant question because it extra important if you go for any type of AI, which depends on data sets. You have to make sure that they're representative. So it would not work if we only collect data in Scandinavia. We would be very good at driving here and probably very bad at driving in other places. So we collect, and that's actually one of the things we do when we still go on expeditions, is collect data sets that are relevant in different places. And then we have partners, and Google Maps, for instance, is good in some places. In China, Google don't even have a map, so there we have other partners to make sure that we have the right map data behind. But our driving scenarios have to be representative, and they will grow. The beauty of the new generation is that you can actually use the consumer cars to collect the data as well, and that means that everywhere there is a car driving, you will have relevant data coming in. Yes?
Does that change the algorithm? Like, do you make a different model for each data set in each country based on their maps and?
Yeah, it's also a very interesting question. We would rather not. And here there's, we actually have a global product, and we would like to make it in such a way that it can handle all kinds of different scenarios. The legislation around data is becoming increasingly local. So in many places now, it's really hard to get data out of the country, which means that we likely in the future will have variants of how our cars behave. Some of them are fine because it's a local thing and we want to adapt to that. But some of them we maybe would have liked to learn from the rest of the world or teach the rest of the world, but we're not allowed to transfer the data. The way we treat that now is that we train our algorithms locally, and then we share those across borders rather than sharing the data itself. That allows us to keep kind of whatever country-sensitive data in that country, but still let the car learn how to behave. Yes?
So actually it's very interesting what you talk about, the fact that some things are local and some things are kind of standardized, and also about LiDAR. So without name dropping, like for instance, Tesla is not believing in LiDAR. So is there also work about, standardizing, about safety? For instance, you showed earlier figures that it's reducing considerably like fatal accidents.
Mm-hmm.
So are you guys trying also to have a standard view on safety and on what is needed for autonomous cars?
And by standard, you mean like a standard that goes across all different cars on a market?
Yes, exactly.
Mm-hmm.
Like driving, some kind of consensus in the industry.
I used to work in telecoms for 20 years, and telecoms is very good at standardizing things. It's the reason why we can use a phone here and in China and in the US and all over the world. It's kind of super good from a user experience. Car industry is really bad at standardizing. It would be great, but I don't think we will see a lot of things standardized. And a part of this is, of course, also competitive, right? People buy a Volvo because it's the safest car around, so they are happy that people appreciate that and actually select that car. But we do this, we would like everybody to adapt what we're doing when it's good, and we would like to adapt what others are doing if that is good. What we try to do is to impact those bodies that, like the NCAPs and others, and basically say, listen, why are we not testing in darkness? If right now, lots of cars can get 5 stars. We would like to actually help consumers understand what's the difference. And then we use the kind of, I would say Zenseact, but that's not true because we're actually a 2.5-year-old company with another company behind us for 4 years. It's Volvo Cars' reputation in this case, and the long tradition of working with some of these bodies that can help actually push that. And then it de facto becomes a standard because people want to sell safe cars. But I don't think we will see true standardization unless it's either laws or it's kind of this type of independent bodies that highlight for the consumer what's safe or not.
But isn't it Volvo that gave away the 3-point seat belt
Yeah.
to, kind of improve safety in cars?
Yes.
So if it's really truly towards zero accident,
Yeah.
it should be also a bit like for everyone.
Yeah.
or
I
for
think
the
it will be,
goods.
and we actually share some of our data sets for the same reason, and especially with like academia and research to make sure that we can actually impact. So I think we will see some of that happening as well.
Thank you.
Yes, good. Many questions. How are we doing for time? 4 minutes left. I don't think I have any more slides, actually. I do. I have one. This important slide. Louise would have killed me if I forgot this. So, the people. I think working in a field like machine learning is very, very interesting because there are no people my age who started their career in machine learning. I mean, of course, there are some people, but on the broad mass of people, none of the 50-year-olds started their career doing machine learning. So people we hire come from all over the world, and they are typically quite young, many of them, and super brilliant. And if I would have, I was asked a couple of weeks ago to give career advice. My only really solid career advice, I have two. The first one I learned from a lady when I was 30. She said, if somebody asks you for advice, they don't want it. So don't give any advice. No matter what they say, they don't want it. I think she was right. But if I anyhow am forced to do it, I think surrounding yourself with people who are really smart and who know things you don't know is like the best thing you can do in a career. Walk into a room and have people around you that amaze you with what they know, and that is our team. That makes my job a lot of fun. So when I talk to people in our company, it's such a great community. We celebrate each other's cultures. On Tuesday, I was out driving autonomously with one of our cars, and one of our engineers said, "Are you going to be in the office on Thursday?" I said, "No, I won't be. I have to go to Stockholm to be in the Women in Tech." And I was like, "Oh, we're going to do our cultural fika and celebrate the Nowruz. I'm going to save you some. Are you there on Friday?" Kind of. And it's so endearing to me because it's really genuine, and it's the community around it, and we are really good at that when it comes to cultural diversity. We are really good at promoting women in leadership roles, but we are too few women. And this is, of course, a bit of an industry problem, and this is, of course, the underlying reason why I love to stand here as well, because maybe some of you will be enthusiastic and tell your friends or come apply. Because we're a little under 20% women, and that is too little, and we have to fix that. So, the beauty of working in a company like ours, in a really big group like Volvo Cars, is we can impact. I mean, you can be a startup and say you want to go towards zero, but if you don't have customers and no cars, you're not going to make a dent in the universe. And of course, Volvo Cars is, in the global scale of things, a rather small car maker, but at least we have millions of cars, right, where we can impact. But we're a company where we work on software and nerd out on machine learning and data, and people like Sophie here build the kick-ass data pipeline and the whole tool chain behind it. We can get to really focus on what we do and work really the way you should do with software. We deploy in our cars all the way to our test cars every day. We deliver to Volvo Cars 20 times per week. We work like you should work with software, and we have engineers who know how to work with software. And that helps a little bit to do in a smaller context. So that's who we are from a cultural perspective. These are our 3 values that we talk about: trust, collaboration, and innovation. And we have a kind of slogan that's called People at Heart. And people are very inventive in the office of making people at heart come to life. And that's one of the reasons I really like to go to work. We have coolest tech, we have a purpose, and we have a team that really, really is nice to each other. And when people leave us, they come back and say, "I miss a little bit what we did, but I miss you guys most." And that's the way it should be, I think. Thank you.